Hi, I'm Mark Sedran. For about a decade, I've been working in the robotics industry. Today, I lead a simulator software group at iRobot. Today, I'm here to tell you a little bit about how we've expanded our RoboMaker implementation. First, though, I'll tell you a little bit about iRobot. iRobot was started in 1990. We've developed some of the world's most innovative robots. Our most popular robot is the Roomba. The Roomba is robotic vacuum cleaner, and right now it's a pretty sophisticated robot. It includes visual navigation and persistent mapping technologies. So why would we need, as an organization, why would iRobot need simulators? So why would iRobot need simulation? So we have bigger problems and we need better tools as time goes on. So as time goes on, we've added more and more robots to our code base, and our code base has gotten considerably larger. So we've gone from thousands of lines of code to millions of lines of code in our production robots. We now reuse code between both our Roomba product line and our Brava product line. These robots, we have various different robot types, and they use all effectively the same code base. Testing these robots is difficult. In the final picture here, you can see a common site at the iRobot office. There's a big pile of robots. As you imagine, some of them work, some of them don't. There's significant code reuse between all of these robots. We have, because it's a common code base, we have both reuse between the different robot types as well as reuse between prototype robots and new feature development. So this really drives our need for as an organization for better simulation and better tools. In late 2019, my colleague Chris Kruger did a presentation at AWS reInvent where he talked about our initial deployment with AWS RoboMaker. In that presentation, he talked about the teamwork that the iRobot DevOps group did between the build team, the cloud operations team, the automation testing team, and the simulator team. And you'll see some of that here. That as I go through this slide, you'll see that the workflow and how we do simulator testing at iRobot spans those groups. And I'll start by talking about how we would have done builds before. So how we would have done builds before in our Jenkins system, and we would have done a build, we would have done unit tests, and that would have been just about it before we handed it off to a wider testing team. What we do now is a little differently. We start off with a Jenkins build. After we complete the build, and so we still run those unit tests, but after we complete that build, we start a Lambda function. That Lambda function reads a test list. It's a configurable test list. This test list gets updated pretty often, where we configure different testing for different types of builds. We then start a bunch of simulator jobs. Our normal testing is about 60 simulation jobs per build, and this testing is done now in AWS RoboMaker. After those jobs get kicked off, we have a Lambda function that checks the statuses, and after that, we compile data into an S3 bucket. So we store all of our logs in S3. Once the jobs are complete, we store some KPI information to Mode. We use that as a tool for tracking status, but our Lambda function also aggregates the tests and give a pass or fail, an overall aggregate pass or fail on our tests. We also provide a URL for all the results and all of the logs that are associated with our testing. And so we do this testing flow on every build that comes out of our Jenkins system now. Now, once we have these builds, there is significant other testing that occurs at iRobot. We have test labs that test both hardware components and software components. We we use both. There's testing for reliability, there's testing for performance. One of the things that we do in our simulator testing is we have modeled many of our environments based on these test labs. So this helps us validate how well our simulation is doing versus real world data. Now, as I talked before, we have lots and lots of robots available, but they are, if we could get to the office, they're all over the office, but obviously that's not always possible these days. A lot of testing is done in employees' homes at this point. One of the challenges with this physical testing is that not everyone has all of the robot types. Not all of our robots are always up to speed. We have a lot of prototype robots that aren't necessarily up to date. And so this presents challenges that simulation helps us overcome. The last part of our testing, and usually the last part of our testing before releases, is beta testing. And this provides real user feedback. Users do love their Roombas. I mean, so we get tons of great feedback from users. We also get a wide variety of environments that the robot is tested in. This certainly helps improve the quality of the software, but also presents the challenge that it's hard to necessarily replicate issues that are seen in these real world environments. It's hard and time consuming to replicate those scenarios. So I'll talk a little bit about why iRobot has chosen AWS RoboMaker as a partner. So the simulation project at iRobot dates back prior to the introduction of the AWS RoboMaker service. We've been working on simulation for a few years at iRobot. Part of the choice of RoboMaker was that it was really using a very similar model to what we were using with Ross and Gazebo for simulation. We used sort of the out-of-the-box components that Gazebo could offer is where we modeled our robots. And another key point here was that we were very easily able to find partners. So the team spans a lot of different, the simulator team spans a lot of different skill sets, and we were able to find both people in those roles and other partners to help us there. Another key point for us was that iRobot already uses AWS for most of the fleet management, all the fleet management at this point. So cloud-connected iRobot robots connect to AWS services. So if I talk back to when the last time we checked in with Chris's presentation in late 2019, he mentioned a key stat at the end that we were running about 5,000 missions per month. So today I'm going to focus a lot more on what's happened since then. And now we run over 5,000 missions a day. Some days we run 6,000, some days we run 4,000, but we do run a significantly higher number of missions than we did 6 months ago. So I'm going to talk a little bit now about what's fueling that growth and what we've learned as time's gone on with this deployment. I'll talk a little bit here about the factors that are driving higher RoboMaker usage. The first thing that's really driving higher RoboMaker usage at iRobot is the workflow that I mentioned before. Every build is running 60 tests, and this is now running across check-ins to our robot code, check-ins to our test repo, check-ins to our tool into one of our tools repos as well. This operation of running these tests on every build when we did that, we more than doubled our RoboMaker usage. This process has significantly driven higher quality in our mainline software development. Our robot quality has significantly increased, but obviously it's driven up our RoboMaker usage significantly. Since we have a code base that's at a mixed stage of development, where we have different robot types, some of which are commercially available, some of which are in various stages of prototypes. Um, and the other thing that happens in our code base is that we have feature development usually for features for released robots. Because we have that sort of mixed use case, it was important for us to have a set of tests that'll run across everything. Generally, our experience is that roughly once a day, these tests will fail. Something is gone. Some change goes in or some attempt at a change goes in and fails these tests. The typical way these tests are failing is that a developer will make a code change and pass for all robot types but one. So that's the typical way these tests are failing. And the sort of one of these a day is a significant number for us, as this is basically a bug a day that we're avoiding getting into the code base and potentially affecting our user experience or our testing experience later down the deployment line. The next factor that's really impacting our usage of RoboMaker is developer testing. So I'll divide development testing into two phases. We have during either new feature development or potentially defect fixing, developers are running significant numbers of RoboMaker tests to reproduce problems. It is particularly helpful for a developer to be able to run 100 tests that are repeating, particularly if an issue is happening one every 10 times. So we can look at rates of failures and not just if a failure happens on a single test. The other factor that's fueling this growth is that our development teams, particularly for new robots, have been very interested in using simulation as a way to jumpstart development before they may even have equipment. Before a prototype robot is available, they'll start running simulations on that new product. These new product teams are actually been quite ambitious, and I've seen a change from these new product teams actually coming to the simulator team and asking and sort of actively pursuing to get tests of their new robot on this list, this 60 test list. This has been a change over the last few months where those teams are interested in both developing on a new simulated platform as well as making sure that other development doesn't affect their development. And that's been sort of a change recently with new projects. The last thing that is currently affecting our testing within RoboMaker is we're running an extensive test suite nightly. So the ambition here is that we will run lots and lots of tests, lots and lots of regression tests, and flag issues that we may find in later testing as we would go down a release branch in the future. The hope is that we will take a release testing cycle that takes about 6 weeks now and condense that. And we hope to condense it both on the front end of making sure that the quality of the software in the main line is better over time. And then we hope to sort of help the other testing teams with potentially replacing some tests that may be executed manually with automation and simulator tests. The last thing that we hope, the last point here is that we hope in the future we'll be expanding our testing in a new dimension. As we spoke before, I mentioned that most of our test environments, most of our simulator environments are actually models of test labs. This doesn't really offer a lot of diversity in our testing spaces, and there's a couple motivations for this. The first motivation is that, as I said before, it's good that we can sort of match simulator data with real world data. The other motivation for this is that it's been particularly difficult for us to expand our simulated spaces and not spend a ton of time doing that. We've had issues with adding specific furniture and adding these models. Adding these models is basically very time consuming. So what we're really looking forward to here is using the new WorldForge environment generator to get us past these hurdles. So what we're looking forward to here is expanding into more diverse simulated spaces as offered to us with this WorldForge with this WorldForge feature of RoboMaker. So what you're seeing in front of you is a Roomba running in a house that was generated by WorldForge. So the left-hand side of the screen is a RoboMaker simulation. This is Gazebo running in RoboMaker. The left-hand side of your screen, the right-hand side of your screen is is a tool that we use within iRobot to give a bunch of data on the robot itself and mapping data. It's similar to tools that are available in ROS. This is a proprietary tool. So the key point here is that this is a space that we didn't have to go in detailed model. We didn't have to spend the time doing the development of it. It came and worked sort of out of the box the first time we used WorldForge here. So this is exciting for us. What we hope to be able to do is both expand our testing into new spaces and get some of that feedback that currently, as a testing organization, we get from a beta cycle that's sort of difficult to replicate. And if we find problems, it's hard to find them again. But we're hoping to get some of that feedback earlier into the cycle. And so instead of making a build, sending it out to a bunch of users, and then finally getting feedback days or weeks later, this is something we can provide and get feedback on performance in a lot of different spaces very quickly. We can do that all without having to spend a ton of time figuring out how each piece of furniture works in the simulator. So I've touched on this a little bit. One of the challenges we've had as a simulator team is sort of presenting issues as real. Not within iRobot, not all developers are using our simulator. Not all product teams are extensively using simulation, but this is always sort of one of the first questions we get asked as we start showing test results. Honestly, particularly when we start showing failures. So the first thing is that we certainly recognize that simulation doesn't test everything. We're running a good part of our code, but we're not running the full end-to-end code path that we've run with a real robot and an app, and we're just not running. So we are fairly focused in what testing we're doing. The simulation runs that we have done that are when we go and we map our data against real spaces that are similar, we do see very similar failure rates and very similar success and failure rates being the same. We do see very similar results when we're modeling in the same spaces. We do see, results that mimic what we see in real world testing. So this is pretty powerful. The more powerful thing, though, for us is when we start combining simulator testing with real robot testing and using results that we can generate in RoboMaker quickly to inform how we spend other testing time. We do have lots of examples in the iRobot code base and in our test plans that sort of are repetitive tests and tests that follow a pattern. And where really we see simulation helping us is being able to run, say, a specific test has to be run 70 times with various variations. We'll run it in the simulator 70 times, and we'll run it only 7 times or a few times in the real world, and really cut down on execution time for testing that doesn't scale as parallelly is RoboMaker. The other thing that we are starting to get asked, and this ties into our excitement for the WorldForge feature, is that we are getting developers asking us for more and more spaces and more. They'll call them, well, I'll call it here realistic spaces, but what we really mean is cluttered, dirty, kind of less sterile environments than we'd see in a lab. more challenging spaces. And again, this is something that I'm really looking forward to not having to develop every piece of furniture on. So this is something that's a challenge for us as an organization. We're hoping to get help with these new features that are coming up. So part of what I wanted to impart here is things that haven't gone well in our, well, maybe not just things that haven't gone well, but things that I would like to have learned earlier in our engagement in the process with our deployment with RoboMaker here. So I'll talk some of the basically lessons learned. I'll go through a few of these here. So early this year, I got an email from our cloud operations manager, and he stated that we, as a RoboMaker group, had generated over a petabyte of log information, and we had basically had more log data within our RoboMaker simulations than all of our robots deployed, millions of robots ever. So this was obviously a problem. We had a configuration issue with how we were purging these logs. But what was striking at this time was we were actually going through some issues with, while we had a ginormous amount of information, we were struggling to sort of make sense of some of it. So we were struggling to answer questions like when a problem first occurred in our code base. We had very good tracking for tests that pass or fail, but we didn't have necessarily good tracking for when the first time an error happened, or execution times, how long it was taking to clean space. So as time goes on, and we're not great at this yet, but as time goes on, what we're really doing is focusing a little bit more on adding, not a gigabyte of logs for every test execution, but some key KPIs every time we execute a test. And that goes to our mode system, and it's queryable, and we're able to track performance over time quite a bit better than we were even a few months ago. The next thing that I would have loved to have learned earlier is that this tool was this RoboMaker tool and this engagement was very, very good at helping us replicate some critical customer issues and some critical crashes that happened to our code base a few months ago. So while it was great at replicating this, we didn't really plan for failures as a use case that we would commonly be exercising. And what I mean by that is, when we got a crash, our procedure started with download a file, and that file was huge. It was like 10 gigs. So we didn't really plan on this happening regularly. And so once we hit these scenarios, it was hard for us to quickly do this kind of analysis. So really what we've learned from that is that we really need to automate information collecting quite a bit better when issues happening. So if a failure happens, we need to have the tools in place to analyze that quickly. That really hadn't happened earlier this year. So this was something that we've really improved over time, but we certainly struggled with early in our engagement. The next piece of info that's been interesting is that when we started with the AWS RoboMaker engagement, we were really concerned with how fast we could run our simulations. So we started off, we couldn't quite run it real time. We quickly were able to scale up and run it 3x real time. This was a very high, it was a key performance metric that we wanted to hit. Ultimately, I'm not sure it was as helpful as we thought. I think some of the thinking that went into pursuing this metric was that we were running previously outside of RoboMaker, so we weren't running parallel systems. We were running a set of desktop systems, and going faster was a huge benefit. Within RoboMaker, when all the tests are run in parallel, the benefit of running faster and faster sort of diminishes somewhat. We do have other parts of the system, whether it's the build or some of the collection of information, that sort of add a bit of time, regardless of how long the tests take to run. So this really, pursuing that high level, high RTFs for all of our tests really wasn't as impactful as it could have been, or as we would have thought it was a year ago. Another key point here is that since we're able to change the time of these tests and how fast they're running, it's always something that we go to, and the team tends to gravitate towards whenever a new problem comes up that we're not able to quickly solve. So it is, and sometimes it is a huge red herring for those investigations. So I'm not sure. In hindsight, obviously, saying we can run simulations faster than real time looks great on slides. It's made for great presentations within iRobot. I'm not sure we really see the complete impact of that, though, over time. So the last thing that we should have planned for earlier is scalability of testing. So we have hit, and when I work you through the flow of how we run testing now, I did it purposely kind of quickly because we are altering that as time goes on. We're planning to implement AWS batches for running our RoboMaker jobs in the future. So that slide will actually look different soon. And the reason we're changing that is because we're hitting limits. We're able to run about 300 or 400, more like 300, 350 tests at a time. But then we start hitting limits of the system, and we're hitting some architectural limits there. So we should have planned for this transition earlier. We expect to be able to run batch jobs at a significantly higher number in the near future. Next thing I'll talk about a little bit here is what's gone wrong, and the video you're seeing is a robot that is about to flip over, and this is one of those examples of things that we really need to refine in our simulations to make sure that we're not that we're reflecting the real world. So next, I'll talk a little bit about what's gone well. I've certainly touted how excellent running lots and lots of jobs in parallel in AWS is as we've gone through this presentation. So as I said early, we run, the milestone now is we run about 5,000 jobs a day. Sometimes it's 6,000, sometimes it's 7,000. We run around that amount of RoboMaker jobs every day. If we aggregate some of these numbers, they give striking amounts of area and time that we spend on every test. So we run about 200. We clean about 250,000 virtual square feet of space every day within our RoboMaker jobs. Every code submission runs about 12 hours of robot testing before it's in this cycle. So it's accelerated by the RTF, and it's all running parallel. But we run about 12 hours of testing. They clean about each code submission does about 8,000 square feet of cleaning. And a key point here is that we're now validating every code submission across 5 different robots. And this is certainly a key where we're all working from home. Most of our developers don't have access to a wide variety of hardware to validate against. This is a huge win for us as a company. So next, I just like to say thank you. So particularly, I'd like to say thank you to the simulator team that supported us through this process. We have a wide variety of skill sets within the simulator team, from modeling the robot to running some of the integration with ROS into our code base, into running tests, into building tests, into running the infrastructure to run these tests, and the team is great. And certainly all of this is a tribute to how well that team has worked, and how well that team has worked with other teams within iRobot. So thank you very much for your time.